if we're finding the product of something, what's happening to them?
Multiply.
Okay.
Oh, sum is addition.
Correct. So if things have the product, it means they're being multiplied. So we're going to use this rule if you have two expressions being multiplied together. Makes sense. All right. So you get given this in the formula booklet as well. So what they're saying is that your function y is two things multiplied together. They've called one of them u and they've called one of them v. Now this is where we are going to use this method. We are going to call one of them u and one of them v, because it's also going to get you into good habits when we look at the next rule, which is called the quotient rule. So this rule here says we've got u, so we leave u on its own, and what we would do is multiply that by the derivative of the other function, plus v left on its own, multiplied by du dx, which is the derivative of that first function. Okay? Now you may be sitting there thinking, what the heck? The method is actually quite straightforward when you come down to it. And the fact that things are being added together means that you don't have to stress about which one is u and which one is v. Okay, you just have to pick one of your expressions as u and one of them as v, and then differentiate. So, here's an example. Now, it may sound silly, but do you recognize that I have two things multiplied together here?
Yes.
Okay? Now, I say that simply because when it comes to some questions, lots of people say, oh, I didn't know which rule to use. Okay, well, if you've got two brackets next to each other, it means they're being multiplied. The fact that they're multiplied tells you you're using the product rule. Okay, I'm going to call this first bracket u, and I'm going to call this second one v. It is unfortunate that u and a v can look quite similar in people's writings, and I do apologise, but that's what they've chosen. So what I'm going to say is u equals 2x plus 1, v equals 3x squared plus 4x plus 2. Now you'll notice in the formula that it's got dv dx and du dx, which tells me that I have to now differentiate those. I have to find du dx and dv dx. So du dx is going to be here, because this was my expression for u. Du dx is 2. dv dx. Oh, okay. dx here just indicates that you are differentiating with respect to x. It's just a fancy way of writing it. So had you had g's here, so if it said 2g plus 1, you would have written du dg. Okay, so that's all that means. Okay, so because our expression, yeah, and that's why in that chain rule substitution we had du on the bottom, because we had y equals u to the power 4. So that's why we wrote dy du.
Does the d stand for derivative?
No, but it's a good thing to think about. Pretend it does. Like, it's all fancy stuff, and none of which is important to your learning, so I'm not going to bother going into it because it's all very fancy. Okay, so we're now going to find an expression for dv dx. What would that be? Tres bien. All we're going to do now is stick these things into that formula up above. Now, as I said, the order doesn't matter. Okay, so if you switch them round, it really is not important. So dy dx is equal to, excuse me, do they put v first? I can't remember. We may as well follow their formula. U first? Okay, so u, I'm going to keep it in a bracket. I've got 2x plus 1. And then they multiply that by dv dx, yes? So I'm going to put 6x plus 4 also in a bracket, but next to each other to show it's been multiplied. I'm then going to shove a big plus sign in between. I'm then going to write v, because that's what the next thing is. 3x squared plus 4x plus 2. And then I'm going to write 2. I'm going to write it in a bracket just to be consistent. Now that is correct. That is fine. If you wanted to do any expansions, you would need to make sure that you're doing them correctly. If you wanted to reorder things, so it's stressing me a little bit that I have a 2 at the end, and I would normally write just a 2 in front of the bracket, but it's not the be all and end all. So if time is ever an issue in an exam, then just leave it as that. You've followed the chain rule, you have things there. That's a correct answer.
So we don't have to add them?
No. And in fact, you wouldn't. You may not be able to, because you may get really complicated things. Now, in this case, we probably could expand this to get a quadratic, or we would get a quadratic. Oh, birdies in here again. And we would probably be able to add like terms here, because we've got no powers. But to be honest, I'm happy if we would just leave it like that. Okay? This one here. So again, can you see that we have 2 brackets multiplied together? Yep. So u equals 4x minus 3. V equals bracket 3x squared plus 1 to the power negative 2. Okay, so u is that first bracket. V is the second bracket. So we're now going to find du dx, which is 4, and we're going to find dv dx. Oh, now dv dx. Yeah. Well, we're going to need to follow the chain rule, aren't we? Because we have something fancy to the power. Okay. So the chain rule is not a standalone rule. Okay, so the product rule is used when we're differentiating products, but within the product rule, we might need to use the chain rule. So the chain rule is a really important one that comes into play over and over and over again, and you're using that within these other ones. Okay, so just be aware of that. It's not a standalone rule. Okay, so product rule is for products. We're going to look at quotients, there for quotients. But for the chain rule, it comes into play for both of them. So as Cameron says, we're going to bring the power in front. We're going to leave the bracket as it is. We're going to take 1 off the power. And then what do we need to do? Multiply by the derivative of what's inside the bracket. Yeah? So in here we've got 6x. Okay, let me just. Okay, so I would actually probably join here my -2 and my 6x. So I've got -12x, 3x squared plus 1 to the power -3. But now I need to put that into my actual product rule. So dy dx. U is left alone. We're multiplying that by dv dx. Oh, that whole thing. Plus v. Multiplied by du dx. And as I said, we could spend a long time going over expanding, rearranging, moving stuff around. But to be honest, my concern is getting you to get this far. If in the real exam they do deduct a mark for not doing something with it, then you can come and shoot me later. But it's less likely to happen than a careless error being made by me confusing you by trying to get you to expand it. Okay, so leave it like that. If you are confident and competent at your expansions and know that you're not going to make a silly mistake, then go ahead and you can start doing stuff. You could, so for example, you could multiply this negative 12x by this whole bracket, because the negative 12x is not raised to the power, it's just the bracket. And you could put the 4 in front, but I'm not going to stress about doing that right now.